Got it. Okay, it looks like that's going to work there. Okay, so today is Unit 7, Lesson 7, and the deadline for everything 1 through 4 is tomorrow. So make sure you get it done. Otherwise, you have the inconvenient hoops to jump through to recover those points. And what else we got? Okay, so let's go ahead and jump right in to. Okay, he's not here yet. Yes. Okay. And it's this period. Here we go. Okay, so we're still talking about libraries and creating and using functions that are pre-written and just sort of from a generally useful toolbox of tools, of function definitions, making sure that they are all local variables. So all the variables for that function definition are contained inside of it so that it can be used on any project. And I think that is the gist of libraries. To say it's running in the background might not be the best description. That's sort of like a, I don't know, but it's preloaded for convenience. Okay, so let's take a look. We'll work through a couple of these. I don't think there's a ton of deliverables more than last time, but yeah, fine. You Career Center at 11, I guess. And yeah, all right. So here we go. Bubble 1, Lesson 7. And if we start from scratch, here we go. And all right, so what do we have here? We have the program uses states library. Does it have any? It does already have the states library loaded. Does it have libraries? I wonder if, yeah, I suppose if you're gonna have and we can take a look at these library functions in block mode. You don't have to copy the library into your main program workspace, but I think it's useful to look at what the library looks like in block mode. I find block mode very helpful, just being visually centered and color based and all that kind of stuff. Okay, so these are all the function definitions from the library. They are using the get column blocks from AppLab, which means they need to have access to the actual table. So in order to use a library that uses get columns, the table needs to be loaded also, because a library is not like another source of information. It's just like an extension of your program code. So anything you use in there, it needs to work as if it was just sort of at the bottom of your program code. But let's see what we have here. Okay, so we have states library. It's already been loaded. And, oh, okay. And US states is a table. The library is called states library that has those aforementioned functions. And I acknowledge your sneeze. Okay, finish the app by writing code inside the new state function by using the functions in the states library. Okay, so new state needs to, which the only function we have here, well, we have the new state function is the one we're going to write, gets called right away, and gets called whenever we click on new state. And the guess button is checking to see if the user's guess, which is getting the property from this, is the same as what was created. Okay, so let's see what we have to do. Let's look at our functions that we have access to. If we go to the functions drawer or toolbox, we definitely need a pick a random state, and we need to set the flag to the flag, and we need to, it's all going to be put, so okay, so current state is going to be our what's going to collect the randomness, which is get random state or states library.random state. And we can prove this by console logging current state after it gets called. Okay, so West Virginia, new state, New Jersey, Alaska, and so on. Okay, already seeing an issue with, what's going on, man? With the fact that the states are coming in initial caps, initial letter capitalized, and we are not sure whether or not the user is going to type it that way. So we're going to have to do a little bit of massaging, a little manipulating to make sure that when we're checking our comparison here, the if statement, it is going to match exactly. So we're going to do our little 2 lowercase. I mean, you could do 2 uppercase, but that's fine. Okay, so new state changes what current state is to something random, and then we need to set the flag. So what is the name of the flag element? It's called flag image. So we're going to do a set image or set property. We can't do set image URL because it's not a URL that we're using. We can do set property of flag image, set its image to, and then this is where we can call our state flag. Okay, and the state that we want the flag of, what just happened? Why is it like that? Don't do that. Did you just press a power? Oh, maybe. I think we lost power here. Can you see if you can track down the source of that missing power? Is it this power strip or underneath? But something just changed. And it's the power for, did yours go out? Yeah. Let's try. Power for this one. No. It's plugged in. That's the strange part. Wait, is this? Where is second? Might go to this one. Where does, let's find one that is. The what? Okay, there we go. I'm not sure if it was too much power going through and it was breaking the circuit there, but let's see. That'd be my only guess is we're we're drawing too much juice. And sorry for those of you who are watching the VOD, if you will. Is the can you press the power for the this? Is it coming on?
Yeah.
Okay. All right. Well, we'll keep going for a second here. Okay. So the parameter that we put here is the state we want the flag of, and we just want this flag of current state. Okay. And that should give us a flag at random every time we click on new state and on every time we click on just run. And we go like this. Okay, and so we are getting current state is being returned, or rather, so the reason why the set property works is because the function we're calling the flag state libraries dot state flag is returning one of the, it returns a flag for the given state. We send it a string and we get back a string. Okay, it's important to have which data type, and data type means either string, number, list, Boolean, those types of things. Those are the data types. Objects, we haven't talked about objects at all, but it that's how we know we can just put it into the third parameter of our set image property. Okay, and no, got it. There we go, and we're back. And if it trips again, that's, we have other issues. Okay, so we are getting current state is changed every time new state is called, which is right away, and also anytime we click on the new state button. And we can now we need, whenever the guess button is clicked, we're getting what the user typed in and comparing it to current state. The problem is, like I said before, is that the states are initial caps. So we need to switch things to either upper or lowercase, switch them both to upper or lowercase in order to have a true comparison, which the way that I would do this, since they didn't give us the 2 uppercase and 2 lowercase blocks here, which I think is a little short-sighted, we're going to change guess state, G-U-S-G-U-E-S, guess state is going to get, has to be spelled correctly, guess state is going to get guess state dot to lowercase capital L O-W-E-R capital C-A-S-E, super important, open close parentheses, otherwise it won't work. Okay, and we'll do the same thing for current state. Current state gets current state dot to lower case, and I'm surprised it's not getting open close parentheses. Let's double check. We can actually put this down here. I mean, don't yet, just because I want to make sure you understand the format. We can't do 2 lowercase before we get the flag, because the flag is based on searching current state with the way it's provided. But we can see if this is working by console logging current state here inside of the new state. Yeah, there we go. Okay, so it's coming through. That is the syntax for to lowercase. But it's fine up here right before, we're only changing it right before we check the conditional. Okay, so we're getting whatever the user types in, we're getting, we're changing that to lowercase, and we're changing whatever the current state is to lowercase, and then we can compare. And I think we are correct there. Let's see what happens. I wonder what state this is. How about Texas? And there we go, correct. And I wonder if we hit, I think this app would, having just played this one time, I think this app is better is if they get it right. Okay, so let's say they get it wrong. Nope, that's not it. You can G-I-N-I-A. If they get it right, call new state. I'm actually not sure if that would work right. Hold off on this for a second. Where you only call new state once they get it right. Is that going to change the yeah, I actually think that's much better to call, because they got it right, you know, go ahead and switch it. But that's not absolutely critical. The critical part is that you are making the new state function change the current state and get the flag of that current state, and also to change both of the strings to all lowercase. And I think that should work. All right, bubble 2. What do we get for this? First, let's take a look at the functions drawer, and we get some cat functions, cats.random breed, breed image, all breeds, and random image. Let's see, do we already have? Yes, we already have the tables loaded. Let's take a look at the library itself. The cats library, which all of this documentation, the comments, everything here is what you get when you mouse over the function call here in the toolbox. Okay. Cats.breed image receives a parameter called search breed, which is you send it a string with the name of the breed you're looking for, and it returns a string which is all URLs of an image of that breed. Okay, so let's see what we have here. We need some program show random cat, name of the breed, every time the user clicks random breed. Okay, library called cats. All right, so first thing we need to do is get a random cat. So let's go ahead and create a new variable, and it's all local is fine. So var here, let's just call it new cat, and new cat is going to get a random breed. God, this mouse is killing me today. A random breed. And then we can set the text of the only text element, which is called breed name, to new cat with no quotes, because it's a variable, not the word new cat. New cat, spelled the same. And we need to set the image. And we can use set image URL here because I guess we could have before. The function, let's look at the library function of set image all breeds. Okay, random image function random image returns breed image, sending it random breed. No, that's random image. That's not what we want. Okay, so here's an interesting thing. This function in the library called random image calls another function that's in the library of breed image, and it sends it a parameter of random breed. That is interesting. Having a return function as the parameter, or technically the argument. When you send it, it's an argument. When the function that receives it, it's a parameter. But having a return function as the parameter is completely normal. But we are only interested in the regular breed image function, which receives one parameter of the breed we're looking for. And okay, so it grabs the 2 columns it needs so that those are local. It loops through the entire breeds list, and if whatever breed it's looking at, or whichever breed it's looking at matches what was sent as the parameter, it returns the whatever string is in images, the images length at that same index, and the images column is a bunch of URLs, which I think all the images for data sets are URLs. But because one of these is what's going to be returned, it can go directly into the set image URL. And so the ID that we want to set is called cat image. Surprise. Oh, well, because it's the image URL. And we want to call as the parameter of what we want to send it is this return function, cats.breed image of which breed? New cat. And I think this will work. There we go. Seems to work. Okay, next one. Okay, bubble 3. Let's take a look at something. Hey, Isaac, are you planning on doing this? Yeah. Fritz, are you planning on doing this? Lucas, are you planning on doing this? Hey, Owen, are you planning on doing this? All right. Hey, Donald, are you planning on doing this? All right. Just a second. All right. Here we are, bubble 3. Let's see what we have. Let's go ahead. Okay, so an important part of writing library functions is testing them to make sure they work before you commit them, so to speak, commit them to your library. And the way you're going to do that for here and for several other applications or opportunities is to run console log statements that will print to the debug console the result of that function. Okay, so we are given 3 return functions, is even, is odd, and is between. And each of these, we've already been given 3 console log statements to test them. And see what happens when we test them. Okay. It looks like we have the first one is even true, is 5 even false, is -2 even true. We are counting negatives as that. Is this the way you got it? Because that seems true, right? All of the first one seemed to work, right? Okay, and the last one is 10 between 0 and 5. True, it is not. All right, so we've got some issues with the last one because 10 is not between 0 and 5, even though it's returning true. 10 is not between 5 and 10 because it's returning true, and 10 is not between 15 and 20, it's returning true. Okay, and the reason this comes out like this is it's just a concatenation of the string of what you're supposed to be testing with this, with the actual return call or return function. That's fine. So clearly there's something wrong with this. Okay, perhaps we are sending the, we're comparing the first, whatever gets sent in first. It needs to be greater than the second parameter, greater than the low, but it needs to be higher than the high. In other words, it needs to be, the problem is if you send the number 10, is the number 10 greater than 0? It is. So the whole statement returns true, even though 10 is not between 0 and 5. The reason is, in order to be between a low and a high, it needs to be greater than the low and lower than the high. And we are checking for or, and with this setup, is any number greater than the low or lower than the high? Every number is greater than, assuming the last 2 are different integers. And the first one, if they were all the same, it would turn false, but that's fine. Either way, the key here is that in order for this to actually check, it needs to be the and comparator. No, what do we call that? Not comparison. Boolean operator. So if we are checking, we need a function that receives one number and checks to see if it's between 2 other ones. That number needs to be greater than the low number sent, and it needs to be lower than the high number sent. Otherwise, it's not between. And now we run it again. And is 10 between 0 and 5? It is not. Is 5 between is 10 between 5 and 10? It is not. 10 between 15 and 20? It is not. Okay. And if you look at the why am I not seeing is between? Oh, these aren't library functions yet, so it's not going to show up here. But if you look at the documentation that would show up in the library, it's a function that's receiving one parameter as a number. The parameter number is a number. The parameter low is a number. The parameter high is a number. But its return is a Boolean, meaning it's going to return a true or false, which you can use in some sort of conditional situation. And yeah, that's useful. All right, so bubble 4. Let's take a look-see. Okay, it looks like we have a lot of return functions that the first, well, they all return a list with a series of one-letter strings in them. And that could be a useful library function just working with letters, and you could check against things, and that's I guess you could work around the to lowercase thing, but that's fine. Let's see what happens. Okay, so down here we have one function called get letters. It receives letter type as a string, either all consonants or vowels. So it needs to be sent one of these three. They're all consonant or vowels. It needs to be the first parameter when get letters is called. And it receives a second parameter, which is a Boolean. It's expecting either the word true or false as the second parameter when get letters is called, like it looks like down here. Okay. The first time, get letters all, and the word all is the first parameter, and the Boolean true is the second parameter, all lowercase and false, and so on. When the function gets called, first it checks for, in this upper level, higher level if statement, which of the three words came through. They're all consonants or vowels. And based on that, it's checking if upper. Okay. And this is when you have a Boolean, you don't need to do if upper double equals true. That would work also, but just if upper, that works. That is the conditional. Okay. So for each of these, it's checking if what was sent as the first parameter, either all consonants or vowels, and this would only work if one of these three was sent. And then it's checking to see if either true or false was sent as the second one. And based on that, it's going to run one of the return functions. So this get letters is a return function that it, based on the conditionals, will call another return function, one of these return functions. And we need to run this to see where it's broken. Okay, we called all uppercase, and we got all the letters uppercase. Good. We wanted all lowercase, and we got all the lowercase. We wanted consonants uppercase, but it looks like we got consonants lowercase. And we wanted consonants lowercase, and we got consonants uppercase. So clearly that's an issue. So when we called consonants true is uppercase and consonants false is lowercase. So inside of consonants, it looks like we are calling lower if upper is true, which you could switch this two ways. You could say if not upper. Actually, I don't know if that's going to work. The easier way to switch is just to switch to call upper when upper is true and lower when it's false. What do you got? Yes. So that should solve our consonants issue. Okay, consonants upper works and consonants lower works. Okay, and then the last one we have vowels uppercase is wrong and vowels lowercase is undefined. Okay, so clearly under vowels, if it's upper, we want it to be upper, and if it's false, we want it to be lower. But you'll also notice that it's just calling the function, which is fine, but that's not what we want. We want it to return. In order to use that function, it needs to be returned. And you need to have that in order for it to work. And I'm going to run this. When I grade your stuff, you need to do that. Okay, so it needs to be a return. it's going, all of these return lists, and the get letters function is expecting to return a list. And so it's calling one of these, it's going to call only one of these return functions, which will send it a list, and they will be able to send a list back to this level. So it's like multi-level. Okay, and I think this is the last one before a checks for understanding. Let's see here. Okay, program design is simple list list library, meaning well, we'll see here. Okay, write test to make sure the first function writes, and then write the second two functions so that they pass the test written. Okay, so we have one function called, do we have anything in the library? I don't think we have a library. Good. This is what your library will look like as you're creating it. And then when you upload it, it will be, here in the managed libraries. And okay, so first function is called fill, and it is supposed to make a new list with the same number, with the same value repeated however many times we send. So we're going to call this function. We need to test this, and the way we're going to test it is with a series of console log statements. And well, we can just do one at a time. It doesn't really matter. But how are we going to test this? Let's test and see if fill, and then in parentheses, I want 10 fives. Okay, and the first thing that comes up in our console log, we have a ton of console log statements, so it's going to be a lot of gibberish at first, but it should be an array with the number 5 written 10 times. And it is. Beautiful. Okay, let's try, and we don't really have to do 3. We can just mess around and make sure it works. How about 1, 99. Okay, it should be a list with a single element in it, and it is. And let's try to break it. How about 1,099s? And there we go. We have an array with 1,000 elements in it. All of them 99. Okay, so having a function, I've actually used or needed a function that created an empty list, or actually a double, a two-dimensional list of lists where everything was a 0 in order to simulate a grid, not a completely useless function. That's a good one. Okay, so we need to finish writing the function multiply by and reverse so that they work as intended. Okay, multiply by, we want to receive a list and have every element in that list be multiplied by a number and have it return a list. Okay, so we're creating a local variable called return list, or a local list, and that's what's going to be returned. And what do we need to do? We need to go through every item in the list that's provided. So let's get a for loop. And we want to do it list.length. And it's only list.length because the word for the parameter coming in is list. But that's a reason why you call it. And then so we want to have our return list is going to take whatever is in list and, well, how about instead of just having a, do we need to do that? Can we just do list at index I gets list at index I times number? Return list. No, we can't change it. Let's just have return list get list. So it's duplicating it. And then we should be able to do for each item in list, return list index I think this will work. Return list index I gets whatever it was before, which is return list index I times number. I think this will work. This just duplicates list. And I think we could probably just do it with returning list, but let's see what happens here with the multiply by stuff. Is that going to work? It does appear to work. Okay. 1, 2, and 3 multiplied by 2 is 2, 4, and 6. And 10, 20, 30 multiplied by 5 is 50, 100, and 150. No, that can't be right. By 5. Oh, no, that's right. Never mind. Forgot math for a second. And negative 1, 2, and 3 by, there we go. Okay, this little trick just duplicates what's brought in, and I'm pretty sure we could just do, I'm going to try something. Let's see if this works. List.length. Let's see if list. Shoot. You don't need to do this part. I'm just testing to see if AppLab interprets things a certain way. Okay, if list index I gets itself times number, return itself. And is that still going to work? Yeah, that still works. You don't actually need a temporary list in there for it to do a return. It still works if you just multiply itself. Okay, and the last one here needs to reverse. All right, so this is a tricky concept, and we need somehow, in order to reverse a list, we are creating a new list. For those of you still pretending to pay attention, I don't think anyone's pretending to pay attention. I think the people that look like they're paying attention are actually paying attention. The rest of you are just stop pretending, which is disappointing. I'd rather you pretend. So in order to reverse a list, we are going to create a new list called a return list. And we're going to do a bunch of appending to that new list. And we need to go through the entire list. The problem is, in order to reverse a list, we need to go through the list backwards. And I don't think we've done any reverse for loops yet. You do need to change a bunch of stuff. Okay, so first of all, we're going to start at the end and keep appending things. Well, ignore this for a second. You don't have to delete it, but just we need to change this for loop to go backwards. Okay, if it was going to go forwards, it would be, well, var I is 0, while I is less than list.length, I plus plus. That's going through it forward. To go through it backwards, that means we're starting I at the last element in the list, which is list.length minus 1. And we want to go until I is 0, or continue while I is greater than or equal to 0. It needs to be greater than or equal to. The opposite of less than is greater than or equal to, not greater than. And we need I to count down by 1. Okay, I is starting at whatever the last element is. we're going to go until I has reached 0, which is the first element. And we need I to go down by 1. So it's going to be I minus minus. Okay, this format is pretty common. And I think we have talked about it before. Anytime you're cutting elements from a list, you do have to go backwards, because otherwise you cut something from a list, everything shifts over, and then you check the next element, which means you've skipped one. So going through a list backwards is fine. Any of those filtering apps, if you went through it backwards, it would work fine. It doesn't matter. Here it does matter because we need to find the last element in list and then append it to our return list. So we want return list to get whatever is in list at index I. I guess now, I don't know, it came earlier. So yeah, I don't know. There you go. And if this works, 1, 2, and 3 should be 3, 2, and 1, and yes, no, and maybe should be maybe, no, and yes. And there you go. It works. We can't do gets when we're doing the return list unless there's already something there. So we can't say return list at index 0 gets list at index I, because there is no index 0 at this point. It worked up here, gets list at index I gets, or really, I'll switch it back to the way it was, which was return list at index I gets list and return list. Return list at index I could get something because there was already something there. Because this is empty, because return list is still empty when we run this, we have to append items, which appends things, adds things to the end of the list. If a list is empty, it just puts it as the first thing in the list, which sort of makes sense. And that should work. All right, so I'm pretty sure this is a checks for understanding, checks for your understanding. And let's take a look at what we got here. Pretty sure it's a pseudocode situation. All right, again, good practice for the multiple choice of the AP test. Okay, AP reference shows how questions, okay, yeah. So our reference sheet as before, it's just our block coding, how procedures work or how they look in a block compared to how they look for our text, procedure name, parameter, and what it does. So following the procedure, determine lists. If a list contains a negative number, if the list contains a negative number, it should return true. Otherwise, it should return false. An error is made in writing this function. So what? So that it does not work as intended. Which line needs to be changed in order for it to work? Let's go through this. Okay. So our function is called check negative, and it receives a list. So we're going to go through an entire list and check to see if any of the numbers are less than 0. So we have a local variable called has negative, and it starts out as true. And it's running a for each loop, which is the same as our for loop doing list.length number of times. Okay, if a number is less than 0, has negative turns to true or is true, and at the end it returns has negative. Okay, why does this not work? Well, let's see if let's try a list. If the number that we're checking is 1, okay, has negative is set to true, and then we're checking, is it less than, it's not, but it's still returning has negative, even though we haven't, even if our list was all 1s, it never could be false. So if you're going to run a loop, like a for loop, and check for something and have it return true if it's true, it needs to start out at the opposite. So line 3 would need to be false. The variable, the Boolean, has negative, needs to start out false, and only switch to true if it did actually have a negative number. And then return whatever it is. Okay, so the answer is line 3. Okay, so that is the end of instruction for today. Do not forget about the, if you are interested at this point, I don't expect people to have done it, but it might be interesting. And I really do I would appreciate somebody taking the practice exam so that I can see what my interface looks like when you send it or when you complete it, and also what access you have as far as, do I need to like release it so that you can take it again? Or do you get instant feedback? I still don't know what the new interface looks like. But if you were to go to the College Board, which lovely is restricted. Let's see if we go to the actual College Board. Again, if you are taking the test, taking the AP test, the most important thing you can do right now is make sure that you can log in to your account. And it's probably a good idea to make sure that, is this going to block me? Oh, good. Make sure that you can get to the part. Why is this update password? I don't like that. Somewhere where it says digital portfolio. Obviously, you're not uploading anything yet, but if you can get to the digital portfolio, you should be able to upload or find the place that you can upload things. But that's it. But the point that I'm talking about is in AP Classroom, which I'm pretty sure this link here will get you to AP Classroom. Otherwise, you can just navigate through the College Board site, which is awesome. Again, I recommend while you're navigating the College Board site, do right-click, open in a new tab, because the site has a lot of loops and a lot of links open up PDFs that you'd probably rather be able to get back to where you were and leave it open. So there's that. But I wouldn't mind if somebody could get to the practice exam in AP Classroom. It's called the 2018 practice exam, and take a stab at it. It's not going to be for points, but it will get your memory stirred, activated, whatever, retrieved for a lot of the topics that we haven't talked about in months. And also see what their programming questions look like and that sort of thing. Okay, so not a bad idea. And yeah, so there's that. Okay, make sure you get lessons 1, 2, 3, and 4 done by tomorrow. I think that's it. All right, let me know if you have any questions.